Hello, everybody, and welcome back to Science for Everyone with Tom Copeland. I'm Tom Copeland. Let's get down to science. So, today we are talking more about covalent bonds. We're going to talk about the difference between a polar covalent bond and a nonpolar covalent bond. Now, if you remember with covalent bonds, they are with nonmetals and they share electrons. But sometimes those electrons are not shared equally, and that's why we have polar bonds and nonpolar bonds. So let's talk a little more about that. First, we're going to talk about nonpolar covalent bonds. Now, nonpolar, it basically means there's not a region where the valence electrons are attracted to. So like think of the North Pole and the South Pole. Those are poles and they're just regions, right? So if we look at oxygen, we have two oxygen atoms here, and each oxygen atom has the same amount of electrons and they're the same distance from the atomic nucleus. So they have the same electronegativity. So since they're the same atoms, and they have the same electronegativity, they are going to share their valence electrons equally. So out of those electrons that are being shared, they are going to spend an equal amount of time with this oxygen atom and an equal amount of time with the second oxygen atom. So since they're sharing the electrons equally, that is what a nonpolar covalent bond is, where they are shared equally. Let's look at another example. Again, this is nonpolar. There's two hydrogen atoms, which is just a proton and an electron. But again, the electrons that are being shared equally because of their electronegativity value, which we'll talk about soon. So if you have two atoms that are the same atoms, they will be forming a nonpolar covalent bond. And of course, they have to be nonmetals as well. Now, a diatomic molecule, if you look at the halogens on the periodic table, we have iodine, chlorine, bromine, fluorine. They form diatomic molecules, and they're mainly gases. And these are also going to be nonpolar because, again, you have two atoms that are the same atoms, the same element, and because of that, they have the same structure, and the electrons are not attracted to the other atom more than the first one because they're identical. So this is another example of nonpolar covalent bonds. We also have hydrogen gas there, nitrogen gas, and oxygen. But atoms that are in a nonpolar covalent bond do not have to be the same element. So here we have carbon and oxygen, we have CO2. So the arrangement of these atoms are basically going to cancel out that electronegativity value, and the structure is going to help it become nonpolar covalent. Now let's talk about the polar covalent bonds. So polar means region, right? So in a polar covalent bond, the electrons are being shared, but they're not being shared equally. So there's an atom that attracts the electrons more than the other atom. And that's because they have a higher electronegativity value, which in a second we're going to talk about that. So let's look at hydrogen and oxygen. Hydrogen only has one electron, and oxygen has 8 electrons and 6 valence electrons. So in order to become stable and form a compound, hydrogen is going to share its valence electron. Oxygen is going to share a valence electron with this hydrogen atom. This hydrogen atom is now stable, and then the second hydrogen atom is going to share its valence, and this oxygen atom is going to share another valence electron with that hydrogen. Now oxygen is stable. But oxygen is a lot bigger than hydrogen, and it has a lot more electrons. It has a higher electronegativity value, which basically is the force that attracts electrons to an atom. So even though these electrons are being shared, they are going to be attracted to the oxygen more, and they're actually going to spend more time with the oxygen atom as opposed to the hydrogen atoms. And oxygen is going to have a partial negative charge because of that. And the hydrogen atoms are going to have partial positive charges. So again, the electrons are being shared in a polar covalent bond, but they're not being shared equally. And then a charge will start to, develop on some of these atoms. Let's look at another example here. So we have nonpolar covalent, polar covalent, and ionic bonds. So nonpolar, again, the atoms are the same atoms and they're going to share equally. But again, they don't always have to be the same element. If we look at this polar bond here with hydrogen and chlorine, yes, they are sharing electrons, but again, since chlorine has a higher electronegativity, those electrons are going to spend more time with chlorine, and hydrogen is going to get that positive charge, that partial positive, and chlorine is going to have a partial negative charge. Ionic bonds is a complete transfer of one or more valence electrons, and in this type of bond, a full charge actually happens. But we're not going to focus on ionic bonds in this video. Okay, so now let's talk more about electronegativity, which again, electronegativity is basically how strongly an atom is going to attract electrons from another atom. So if we look at this chart, these atoms all have their own electronegativity value. So how strongly are they going to attract electrons to them, right? So how do you use this chart? It's actually pretty simple. You take the two values of those two atoms that are forming that bond, and all you do is just subtract them. If you get a value less than 0.4, then you will have a nonpolar covalent bond. If that range is in between 0.4 and 1.8, then you will have a polar covalent bond. But if it's higher than 1.8, you're going to have an ionic bond like NaCl. This is important too. These values, if you look online, you may see slightly different values. It may not always be 0.4. It might be 0.5 or 0.6 or 0.3. And for 1.8, it might even go up to 2. So there is some, arguments on, what exactly should the cutoff be. So just keep that in mind. This is a pretty good indicator, but there are, slightly different charts out there, and that's important to understand. So I hope you've started to understand the difference between a polar covalent and a nonpolar covalent bond. They are sharing electrons, but in a nonpolar, they are sharing electrons equally, and in a polar covalent bond, there is an unequal sharing of electrons. Until next time, keep on sciencing. Does that even make sense? Sure it does.